Number 4, the first thing we are asked to find is the y-intercept. That is where the graph crosses the y-axis. So the answer to part A is the point 0, 0. Depending on your answer choices, it could also be y equals 0. Positive intervals. The positive intervals are where the graph is above the x-axis. So in this case, or in every case, it would be whatever section falls above the x-axis. So you're going to use the x values to state those. So this section starts at -8, goes up, it stays positive, and then it stops being positive right here when x is 0. So that would be square bracket -8, 0. Then nothing's positive for these x values. Then starting right here again, this section is positive. Since that does not cross at a whole number, you have to do a little bit of an estimation. I just went ahead and said that that was 6.2, comma. And since this graph keeps going forever, as it keeps going to the right, the x values are going towards positive infinity. The negative intervals are the x values where your graph is below the x-axis. So for part C, this is the only section here that is below the x-axis. It starts being negative here, comes over, stops being negative there. So this x value right here is 0. This x value right here is 6.2. Absolute maximum is the absolute highest point of the graph. So if you follow your graph up, this is a high point, this is a low point, and then this graph keeps going and going and going and going and going. So in this case, since the graph keeps going up for part D, there would be no absolute maximum. This other high point, this other peak, this would be a relative maximum if this problem asked you for it. So a relative maximum is just any high point, just not the highest. And this would have been the point -4.8. Absolute minimum is the lowest point possible on the curve. That would be right here at the point 4, -4. I'm sorry, 4, -5. It's hard to read with all of my scribbling. That's the point 4, -5. And then end behavior always starts off the same way. As x goes to -infinity, and then as x goes to positive infinity. So as x goes to -infinity, we're going to follow our graph to the left. Our graph stops right here. So we need to follow it over. And that means that y just goes to 0, comma, y goes to 0. As we go from x goes to positive infinity, we're going to follow it to the right. It keeps going and going and going forever right. It also keeps going forever up. So y goes to positive infinity. Taking a look at number 5. Number 5 wants increasing intervals first. So increasing, we're going to start from the left of the graph. And this section goes up. So that's going to be our increasing interval. Well, where does our increasing interval start? So this arrow means that this graph keeps going and going forever to the left. So we don't know where it's coming from. So we're going to say -infinity. And it's increasing, 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 increasing until we get to right here, which would be the x value of 0. Part B is your decreasing intervals. Well, decreasing, once we hit this 0, this other side, the y values go down, or this part of your graph has a negative slope, and it keeps going and going and going forever. So it starts decreasing at 0 and keeps going to positive infinity. Part C are the positive intervals, and that's the interval of x values that are above the x-axis. So we're talking about this section of the graph. So from -6 to +6. Negative intervals are the section of the graph that's below the x-axis. So it's from the arrow all the way to -6. So the arrow is showing you negative infinity to -6, and then over here, 6 to positive infinity. Part E, end behavior, starts the same way every time. As x goes to negative infinity and as x goes to positive infinity. So as we follow our graph to the left, our graph never stops going down. If the graph never stops going down, that's when y is negative infinity. On the right-hand side, as x is getting bigger, we're moving to the right. This graph still keeps on going down over here. So again, y goes towards negative infinity.